Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. So far we've built the intuition for sample selection bias and understood why it arises. But how much can it actually affect our estimates? So in this video we'll compare what happens when we estimate the same regression using 1, the entire population, and 2, a selected sample. Now, keep in mind, the model doesn't change, the true relationship doesn't change. The only thing that changes is who appears in the dataset. Keep in mind, this was the cleanest way to give you a visualization to see how sample selection bias works. So hold everything fixed and vary only the sample. The difference in estimates will basically be entirely due to the selection. The research question we're going to look into is, how does the exam score depend on study hours? And imagine this relationship exists for every student in the population, those who study a lot and those who barely study at all. And we want to recover the true beta 1, so the true return to studying. If we had the entire population, let's say we've got here X, this is your study hours, and here your Y is exam score. Okay. You would have both low studiers, average students, high studiers. So you would have some that don't study a lot here, you would have some more that study here, and you would have the others who study a lot. Okay. And if I were to fit a regression in here, line would probably look something like this. If we could observe every student, the full population, this is the relationship that we'd estimate. And the line would capture the true average effect of studying on exam performance. Keep in mind, we would have had the ones that don't study a lot down here, the one that study an average amount of hours here, and here the ones that study a lot of hours. This, keep in mind, the line that we just did here, this should be the true relation. If full population. Okay. Let's say now that we observe students who actually sit the final exam. So we only see students who sit the final exam, which means who is going to miss if we only observe students who actually sit the final exam? Well, it could be that the ones that we're missing are the people who dropped out during the course. It could be students who never attend it regularly. It could be that it's students who withdrew before exams. And students who expected to fail and show not to show up, so the ones that maybe defer. So ultimately, students who show in the data, who show at the exam and clearly who show in your data, is going to be only the ones sitting the exam. And this isn't random. The students who didn't sit the exam are unlikely to be a random cross-section of the population. They will be systematically different, and those differences are related to exam performance. So what happens next? Well, let's say we remove from the scatter plot that we had here, we're going to mostly remove low study hours, very low expected scores, and any like lower left cluster in this entire scatter plot. So technically, I'm getting rid of this bubble in here where I had all of these students. So I'm going to take away these two. Okay. Now, we haven't changed the relationship. We haven't changed the model. We've simply changed which observations we can use. So right now, the ones we can use are only the average studying people like hours and the high study hours. So the lower left corner of the scatter plot has completely emptied out. The students who study least and perform worst have disappeared. So what's going to happen now to this regression? Well, if I look at it a little bit better, now it seems that maybe a line that goes more like this is maybe a better fit this time. Okay, or maybe we can see another one that is slightly better, actually. Maybe the one that goes through here. Okay, that looks like a much better fit now. Keep in mind, the slope could have been flatter like the purple one in here, or could have been the blue one. Keep in mind, the intercept would have also changed it, so the slope would have changed it. The thing that you should take away is that we no longer looking at this original true relationship that we have, because now we are thinking that there is a better estimate in there. And the thing is that both lines, so let's say in this case, the red and blue one, they both estimate or are estimated correctly by OLS. And the difference between them is entirely due to who is in the data. So why were those students missing? They were not missing by chance. The same factor that led them to miss the exam, low engagement, poor preparation, difficult circumstances, are exactly the factors that would have produced those low exam scores. So in this case, the selection process that we did here is correlated with the outcome that we are trying to explain. And that's what's creating the bias. So in here, what we're doing is like we're putting in actual with an example, the path diagram that we saw in the previous video. The unobserved factors driving the selection are the same ones driving exam performance, the outcome. And exactly the hidden connection that we drew in that diagram. So if both regressions are computed correctly and OLS is doing exactly what it's supposed to do in both cases, then where's the difference? The difference is in the data that it's working with. And this is one of the most important messages when it comes to non-random sampling. So a technically correct regression, but on the wrong sample, will still give you the wrong answer. As a second example, think about labor economics, population. You have all working age individuals, and the observed sample is that you have only employed workers. Can we estimate the return to education for the full population? Not necessarily. The regression reflects the relationship among those who found employment, and who are systematically different from those who didn't. So the unemployed aren't missing by chance. They are missing because of factors like skills, motivation, labor market conditions that are also related to the wages that we are trying to explain. So, sample data selection bias doesn't arise because OLS makes a computational mistake, but it is because the problem is in the data, okay? So the regression answers the question, what is the relationship between studying and exam scores among students who sit the exam? But the answer that we wanted should have been, what is the relationship between studying and the exam scores for all the students? And those are different questions. And sample selection makes us answer the first when we meant to ask the second. So now we've seen how sample selection bias distorts our estimates, not because OLS fails, but because the data it receives is unrepresentative. So the obvious next question is, can we adjust for the fact that our sample wasn't randomly selected? And we'll do that in the next video, so stay tuned and I'll see you then.